This is day 2 of Unit 8. We started with this warm-up, so take a moment and pause the video, try the warm-up, then play to check your answers. So page 2, problem 33, asks for the explicit formula. So first I'm going to start with a sub n equals, and then hopefully you realize by looking at that problem that the d value is 3, and the a sub 1 is equal to negative 12. So negative 12 plus 3 times the quantity n minus 1. And then distributing gives me 3n minus 3. So negative 3 and negative 12 give me negative 15. So 3n minus 15 is equal to a sub n. That's my equation. Next one, number 2, is on page 2, problem 36. So that asks for the recursive formula. Recursive formula we know is a sub n equals a sub n minus 1 plus d. Well, d in this problem is 200, so plus 200, and there's my recursive formula. Next one, number 3. So it asks us to do find the 7th term of the sequence with a50 equals 488 and d equal to 10. So I'm going to substitute the 50th term, 488, in for a sub n. And the first term, I don't know. So a sub 1 plus d, which is 10, times the quantity n, and excuse me, which is 50, minus 1. So I don't know a1, but I do know that 50 minus 1 is 49. So I have 488 is equal to a sub 1 plus 490. And subtracting 490 from both sides, I have a sub 1 is equal to negative 2. So if I know a1, then I can get what I'm looking for, which is the 7th term. So back to the explicit, I'll just put that here. So we have a sub 7 equals the first term, which we just got, negative 2, plus 10 times 7 minus 1. So the 7th term equals negative 2 plus 7 minus 1 is 6. So 6 times 10 is 60. There we go. And 60 minus 2 is 58. So the 7th term is 58. Next one, number 4. So I'm trying to figure out whether this is arithmetic, geometric, or neither one. Well, if I do 1 minus 1, that's 0, and 2 minus 1, that's 1, not getting the same value, so it's not arithmetic. 1 divided by 1 is 1. 2 divided by 1 is 2. I'm not getting the same value, so I know it's neither. But then I do have to figure out what the pattern is in order to get the next 3 terms. So the pattern, hopefully you recognize what the pattern is. If I add the first 2 terms, 1 plus 1, I get 2. 1 plus 2, I get 3. 2 plus 3, I get 5. 3 plus 5 would be the next term, which is 8. 5 plus 8 is 13. And 8 plus 13 is 21. That, by the way, that sequence, it's not arithmetic or geometric, but it has a special name. It's called the Fibonacci sequence. It's named after the person who discovered it. That's the Fibonacci sequence. So 1, 1, 2, 3, 5, 8, 13, 21, and so forth. Adding the 2 previous terms to get the next term. Okay, so that takes care of the warm-up. So most of the problems that we're going to look at today in class are from the worksheet booklet. So we're in worksheet number 1, problem number 5, and remember we're in Unit 8. So take a look at that. So this is talking about the recursive formula and the explicit formula. Well, these were actually in the homework last night, and they are geometric equations or sequences. Hopefully you realize that. I wanted you to just realize they were geometric and that you couldn't use the arithmetic formulas. And now today we're going to talk about what the geometric formulas are. So before we go ahead and do this problem, let's first talk about the formulas. Well, if you recall from yesterday, the recursive arithmetic formula is a sub n equals a sub n minus 1 plus d. Well, if you think about it, the difference between an arithmetic sequence and a geometric is that we multiply by the r value rather than adding the d value. So that's exactly the difference in the equation. The geometric recursive formula starts off the same, but instead of plus, it's times, and instead of d, it's r. Okay, which hopefully that makes sense to you. It's the exact same formula, except for with arithmetic sequences, we're adding, so it's plus, and with geometric sequences, we're multiplying, so it's times. We use d because that's common difference. We use r because that's common ratio. So similarly, the explicit, arithmetic explicit formula, we remember from yesterday, is a sub n is equal to a sub 1 plus d times the quantity n minus 1. Well, with geometric explicit, it starts off the same. A sub n equals a sub 1. Now, rather than adding, it's times, which again should make sense. Rather than d, it's r, which should make sense. And here, when we're repeatedly adding something, we know that translates to multiplying in equations. Well, when I'm repeatedly multiplying by something, we know that translates to exponents. So rather than being d times the quantity n minus 1, it's going to be r raised to the n minus 1 power. Again, hopefully that makes sense. Repeated multiplication is shown in math with exponents. So those are our equations. So now that we know them, let's go ahead and try problem number 5 on worksheet 1. So 3, 9, 27, 81, all I'm going to do is substitute into the equations. So for recursive, a sub n is equal to a sub n minus 1 times the r value, which is 3. For the explicit, a sub n equals a sub 1, which is 3, times r, which is 3, and that's raised to the n minus 1 power. Okay, so that's my recursive and my explicit. And then it says to find a sub 11, so I'm going to use the explicit. Remember, the recursive, I don't know the 10th term, so I can't get the 11th. But I can use a sub 11 is 3 times 3 to the 11 minus 1 is the 10th power. And 3 times 3 to the 10th is 3 to the 11th. So if you type 3 times 3 to the 10th or 3 to the 11th in your calculator, you should get this term, which is, what is that equal to? This is problem number 5 on worksheet 1. It looks like 177, 147. Okay. All right, next in class, I had students try problem number 7. So take a moment, pause the video and try it, then play to check your answers. So number 7 was -1, comma 2, comma -4, comma 8. So if I'm writing the recursive, a sub n equals a sub n minus 1 times the r value, which is -2. And the explicit, a sub n equals a sub 1, which is -1, times r, which is -2, raised to the n minus 1 power. And that's our explicit. So if I want the 15th term, a sub 15, I substitute 15 in, -1 times -2 raised to the 15 minus 1, or 14th power. When -2 to the 14th is going to be a positive number times -1, that's going to come out to be negative. And you can just type that in the calculator. -16384 is the 15th term. Okay, so that takes care of number 7. All right, next we tried this one. So this one looks similar to a problem we did yesterday, except for yesterday we had a d value. Now we have an r value. So hopefully you realize that that means this is a geometric sequence. So if it's geometric, I'm going to set it up the same way. It says first 5 terms. Remember, when there's not very many terms, you can just go ahead and make the lines. So I'm going to make those lines, and I'm going to put on the second line -6. So it says geometric, and -2 is the R value, which means to get these next three terms, I just multiply by -2. So positive 12, -24, and positive 48. And to get this previous one, I'm going to divide by -2 to get the term right in front, which would be 3. And work-wise, you would just show me what you did there. You divide by -2, and all of these are times -2. Okay, that takes care of that. Next one, this is problem 20 on worksheet 1. So we're going to find the seventh term of the geometric sequence where a sub 1 is 81, a sub 5 is 16. So we are going to do this the algebraic way. We're going to use the explicit formula. So a sub n is equal to a sub 1 times r raised to the n minus 1 power. And I'm going to substitute in what I know. So I know the first term is 81. I don't know the r. I do know that the fifth term, so I'm going to go ahead and put 16 in for a sub 5, and I'm going to put 5 in for n. And I'm going to solve that. So I have 16 is equal to 81 times r to the fourth. And I'm going to divide both sides by 81. And I'm going to solve that by taking the fourth root of both sides. I'm taking an even root of something to an even power, so I know that's the absolute value of r. And the fourth root of 16 I know is 2, and the fourth root of 81 I know is 3. So that means that r is equal to plus or minus 2/3. So that, hopefully you noticed on the previous problem, let me go back a second, that when r is negative, every other term will be positive and every other term will be negative. So here, we're getting both positive or negative, which means we could potentially have two different answers when we find the seventh term, depending on which term we end up on in the sequence, whether it's going to be positive or negative. So we have to plug in r is positive 2/3 and negative 2/3 to see whether we're getting the same answer or one answer that's positive and one that's negative. So we're going to find a sub 7, again using the explicit. I know the first term is 81. I now know the r value. I'm going to use 2/3. And I'm plugging in 7. So 7 minus 1 is 6. So I'm taking 2/3 to the 6th times 81. And when I do that, let's see, what am I getting here? I'm getting 64/9. So that's one of the answers. That's using r as positive 2/3. Now I'm going to take a look at this and see if putting a negative 2/3 in affects my answer. Again, sometimes it will, sometimes it won't, just depending on which term you're looking at. So I'm plugging in 7, so 7 minus 1 is 6. So here, whether r is positive or negative, it's not going to matter because a negative to an even power is a positive, and a positive times a positive is a positive. So this is also going to end up 64/9. So because it was the seventh term, it didn't really matter. Now, had I asked you to find the 6th or the 8th, remember, because of that every other term being positive and negative, if I asked you to find the 6th or the 8th term, then using r as positive 2/3 would give you a positive number. But using r is negative 2/3, we'd get a negative number. So we wouldn't get the same answer. Regardless, you need to do both ways with both the r values to see whether you're getting the same answer or not. Okay, so there we go. We have our seventh term. Next one. So this is geometric. We did a problem yesterday similar to this, but it was arithmetic. So it's geometric, and I need to find the missing terms in between. If you recall yesterday when it was arithmetic, we added these two numbers and divided by 2. We found the arithmetic mean, and that was the middle number. Today, we are still going to involve the 4 and the 324 to help us get that middle term there, but we're not finding the arithmetic mean, we're finding the geometric mean. And the geometric mean, in order to find it, what you do is you get the product of those two numbers, so we multiply them, which that should make sense, geometric, multiply. But then rather than dividing by 2, what you do is you take the square root. So I'm going to multiply 4 times 324. And then I'm going to take the square root of that product. And that number will be the term that's in between there in the center. So if we do that, we are getting 36 is that middle term. Now, once I have that middle term, I can do that again. So the square root of 4 times 36 will be this number here, and the square root of 36 times 324 will be this number here. So those two numbers are 12 and 108. Okay, and that's how you do problems like that. Okay, this example is not in your packet, so you'll have to write this in your notes. So we want to find the 10th term of a geometric sequence where the 9th term is 31.25 and the 12th term is 3.90625. Now, students suggested a couple different things in class. Someone suggested we use the recursive formula, and I think the reason they thought that was because we know the 9th and we want the 10th. So that's good thinking, except that we don't know the r. So remember, the recursive formula, a sub n equals a sub n minus 1 times r. If I knew r, then I would multiply that by the 9th term and I would get the 10th term, but I don't know r. So I can't use the recursive formula yet. Also, someone suggested, well, can't we do the problem like the last problem with the lines? Well, we can try that. So if I'm starting with A9, I'm going to go ahead and put that 31.25. Then the next term would be A10. And then A11 is another term, and then A12. And A12 is that 3.90625. Okay, so someone said, well, can't we get the geometric mean? Well, look at that. There's an even number of numbers in between this time, so there's not a middle. So we can't really get the geometric mean. That won't work. So we have to approach it differently. We're going to have to use the algebraic approach. So if we can't use a recursive formula and we can't use the lines, really the only other way to do the problem would be to use the explicit formula. So we know the explicit formula, a sub n equals a sub 1 times r raised to the n minus 1. But you're probably looking at that and saying, but I don't know anything. I don't know the first term, and I don't know r. I do know the 9th term, and I do know the 12th term, so I could put either 12 or 9 in for n, and then substitute in for a sub 9 and or a sub 12. So we could substitute in here and substitute in here for n, but we still have two variables, and two variables in an equation is not good, right? You can't solve an equation that has two unknowns, two variables. So here's what you have to do. You have to kind of manipulate the equation, the explicit formula, a little bit. If you think about it, the equation that we're going to write here describes the pattern between the numbers. And this pattern, this equation, really shouldn't matter whether we start the sequence at the first term, A1, all the way down here, or we start it with the 9th term, because the 9th term is the first term that we know of this sequence. So I'm going to adjust this formula a little bit to start it at the 9th term rather than starting it at the first term. So in other words, rather than using a sub 1, I'm going to use a sub 9. Now, if you're not sure where that came from, that's the first term that was mentioned in this problem. So that's why I'm using that first, just like we normally use the very first term of the sequence. So in other words, I'm writing the pattern, the formula based on the pattern of the sequence. And that, like I said, that equation is going to be the same whether I start it at the 9th term or whether I start it at the initial term. The only thing that's going to be different is the starting spot, but the pattern itself is the same. So I'm going to start it at the 9th term. I still don't know r, but I do know that normally when we started at the first term, we have to subtract 1. So now I'm starting at the 9th term, which means I have to subtract 9. And then the other term I know is the 12th term, so I'm going to put A12 here. So if I'm putting A12 there, then I'm doing 12 minus 9, because n is 12. Okay, and you are allowed to do that. You may adjust the formula to make it match what you are needing to do, which is we need to start it at the 9th term and end it at the 12th term. So rather than n minus 1, it's n minus 9 because we started at the 9th term. And the n is still there and the A12 is still there. So I'm going to go ahead and put 3.90625 in for A12. I'm going to go ahead and put 31.25 in for A9. And I don't know r, but I do know that 12 minus 9 is 3. So now I only have one variable, and now I can solve. So I'm going to divide both sides by 31.25. And when you do that, you should get 1/8 is equal to r cubed. And we know to undo a cube, we take the cubed root. And we know that, hopefully you know this without a calculator, that the cube root of 1/8 is 1/2, because the cube root of 1 is 1 and the cube root of 8 is 2. So now we know r. And as we said earlier, now we can use the recursive formula because we know r and we know the 9th term. So I can take the 9th term times the r value to get the 10th term. So a sub 10 is going to be a sub 9 times 1/2, which means I'm going to take the 9th term, which is 31.25, and I'm going to multiply that by 1/2. And when I do that, I should get my 10th term, which is 15.625. And there we go. We have our final answer. Okay, so that's the 10th term. Yeah, I just want to point out, and we'll do some more of these in the next couple of days, but not only are you able to adjust the explicit geometric formula, which is what we did here, changing the 1 to a 9 and then this 1 to a 9, but you can also adjust the explicit arithmetic. So we know a sub m is equal to a sub 1 plus d times the quantity n minus 1. Same thing if I had, let's say, same thing, I had the 9th term and the 12th term. I could put a12 here, a9 here, d times 12 minus 9, and I could solve for d. Okay, so you can also adjust the explicit arithmetic formula in the same fashion that we adjusted the explicit geometric formula. So it doesn't necessarily have to always start at the first term. If you have information further down the sequence, you can use that information and substitute in here. Okay, so it basically is just pushing the sequence further down the line and starting it there, but the pattern still remains the same. Okay, so that's it for today's lesson. Your homework is worksheet 2, all of it, and worksheet 1, finish it up. I think we've done most of it now, but you're going to finish that up for tomorrow.